3I Atlas makes its closest approach to Earth. A new, independent way to measure the Hubble Constant. Are Uranus and Neptune actually rock giants? And Jared Isaacman is the new NASA administrator. All this and more in this week's Space Bites. So we haven't had much news from Comet 3I Atlas for the last couple of weeks, but at the time that I'm recording this, we are one day after Atlas's closest approach to Earth. And when I say close, that is a relative term because it has come within 269 million kilometers of Earth, or 1.8 times the distance from the Earth to the sun. You know, imagine the distance from the Earth to the sun and then almost the same again on the other side of the sun. So it is still very far away. And yet this is the closest point. And so this is our best chance to take pictures of this comet as it goes past. And so while we are talking about this now, astronomers are busy taking pictures, and I'm sure we'll be rolling those out in the next couple of days. But we do have some pictures that were taken in the days leading up to this closest approach. So first up, this is an image from the Gemini North Telescope, which is located atop Mauna Kea in Hawaii. And this is an 8-meter class telescope, one of the biggest in the world. And you get this really beautiful picture of the comet with this giant coma around it. And as you can see, it has a green glow, and this is coming from the diatomic carbon that is making its way out of the comet into the coma. And this is a very reactive chemical, and it takes a bit of a delay. So when a comet makes its closest approach to the sun, which it did back about a month ago, then it has to get warmed up, and it takes a while for that heat to seep into the comet and raise its temperature to the point that this diatomic carbon gets out, and then that chemical changes the color of the comet to be more green. And in fact, you can compare what 3I Atlas looked like now to the one that was taken back in September by the Gemini South Telescope. And what's great about this is that the Gemini North and the Gemini South are essentially identical telescopes, one in the northern hemisphere, one in the southern hemisphere. And so, you know, with similar instruments, similar size, and so you get a sort of apples to apples comparison. And you can see the configuration of the tail, and you can see that the comet has a more reddish color. And this is a very common thing. As comets get very close to the sun, the heat from the sun, the radiation, causes different chemicals to be more present in the coma, and that changes the color of the comet. And then we've got some images from an X-ray observatory, the European Space Agency's Newton telescope. And this image is like not as pretty as the ones that were taken by the visible light telescopes, but there's a lot of interesting science that's going on in there. You get the radiation coming from the sun. It is interacting with the chemicals in the coma, and it is releasing X-ray radiation, which we can then observe with X-ray telescopes. And from that, astronomers are able to, again, confirm the presence of different chemicals in the coma, like this diatomic carbon, carbon dioxide, carbon monoxide, and then compare the amounts of these materials in the comet to what we'd expect to see from a comet that came from the solar system, a long period comet, a comet that comes back on a regular basis. We're getting this deeper insight. And so now Comet 3I Atlas will continue on its way out of the solar system. There's one more encounter with Jupiter. It's not going to get that close. And there's a couple of spacecraft that could get within, say, 10 million kilometers of the comet. And so that'll give us another chance to make some observations of it as it is speeding out of the solar system. And then eventually we will no longer be able to observe it, and it will just enter the history books, and we will wait for the next interstellar object to come through the solar system. Now, we've got a lot of coverage about this over on Universe Today this week. So we've got stories by Matt Williams, Evan Goff, and David Dickinson. All right, it's time to talk about the Hubble tension. And this is something we've talked about many times in the past, you know, the crisis in cosmology. And the problem is that when you measure the expansion rate of the universe nearby to us, you get an expansion rate of 73 kilometers per second per megaparsec. And then when you measure the expansion rate in the cosmic microwave background radiation, you get 67. And so there is a gap between those of about 6. And the measurements of both of these have been done so well that their error bars no longer overlap. And so now the question is the nearby measurement wrong? Is the distant measurement wrong? Or did the universe do something weird in between those times? It, change its expansion rate. And this is something that astronomers are still trying to figure out. And so all of the measurements that are done relatively close to the Earth, and by that I mean like to a few billion light years, the Cepheid variables, the Type 1a supernovae, and other methods of measuring distance give you this 73 number. But the hope is that there is something that astronomers can use to measure that was closer to the beginning of the universe, not within, say, a billion light years of us, but something that was 12 billion years ago. That would be great. And you run out of a lot of options at those distances. All you're kind of really left with are quasars. Now, quasars are incredibly bright, and astronomers have proposed ways that they could be used as standard candles, ways to measure the expansion rate of the universe. But quasars are, not very easy to know what is the intrinsic brightness of an actively feeding supermassive black hole, although there are some ideas. But astronomers have come up with a new technique which allows them to actually use the light from a quasar to measure the expansion rate of the universe. And it's actually not because of the quasar, although it's sure helping, it's from a gravitational lens that is positioned in between us and the quasar. It could be a galaxy cluster that is focusing the light of this more distant quasar. And the light can take multiple paths around the gravitational lens. As you can see in a couple of these images, there are these bright spots around the gravitational lens. That's just one quasar. It's just that the light is being bent around it multiple times. And so if something happens in the quasar, then the light is going to come from the quasar. It's going to follow and wrap around the gravitational lens, and we're going to see a slight difference in the timing for when that event happens. So you can actually tease out the expansion rates of the universe depending on which path the light has followed. And so astronomers have watched for flickering of light in the quasar, looking for events that happen, and then watch as those events unfold in the different reflections, the different versions that they see in the gravitational lens. And from that, they were able to calculate that the number was 74.3 kilometers per second per megaparsec, which is in line with the local measurements. And so you're kind of getting this compression of whatever if the universe was doing something weird, it had to have been doing it very early on in the universe. Sometime that was after the cosmic microwave background radiation was released, but before we're seeing the light from these quasars. So the mystery continues. And we've got a story from Andy Thomaswick about this on Universe Today. Traditionally, Uranus and Neptune have been classified as ice giants. And what that means is that while Jupiter and Saturn are gas giants, they are made of hydrogen and helium with a lot of rock and a lot of ices and other stuff. If you were to take Uranus and Neptune and cut them open, they would be filled with something that we would consider to be ice. Now, not necessarily just water ice, although that's a lot of it. There's also other volatile elements that are inside of it that are under enormous pressure and act like an ice. And it's always known that they would have some kind of rocky center as well. But there are a bunch of anomalies that have been really difficult to explain about Uranus and Neptune. And part of the problem is that we only have one close-up flyby of both of these planets, thanks to Voyager 2. It flew past Uranus in 1986, it flew past Neptune in 1989, and then that's it. And nobody sent a mission back, which we absolutely should, and I am obsessed with this. But anyway, so one is the sort of gravitational field of both of these planets as the Voyager spacecraft was going by, and then the other one was just the shape of the magnetic field and the strength of the magnetic field that Voyager was able to measure as it went by. And so a new paper has come out that says, well, the best way to explain the detections made by Voyager is that they're filled with rock, not filled with water ice. And so they did a bunch of simulations, and they found that when you got to this place where it was predominantly rock in the interior of Neptune and Uranus, you were able to get layers of what's called ionic water, which as it moves can help generate a magnetic field. And that the layering that you got with the rock and some of the water, it matched what the Voyager spacecraft saw as they flew past these planets. And then one other really big hint is that when you look at the composition of Pluto, it is probably 70% rock and 30% water. And it is in the exact same zone as Uranus and Neptune. And so it's very strange that Uranus and Neptune would have much smaller quantities of rock compared to what Pluto has. And so maybe they're much more rocky. And in fact, now I'm going to rabbit hole, but this is starting to match some of the ideas that astronomers are having about extrasolar planets, that, it could be that super Earths, which are, planets with many times the mass of the Earth, are really just stripped down mini Neptunes, that, they had some kind of rocky interior and then a surrounding area filled with other gases and volatiles, and they were closer to the star. And so that was all sort of blasted away, and you're left with this interior. So the bottom line is we've got to go back. We've got to send a mission back and do some really careful gravitational measurements, magnetic field measurements of both Uranus and Neptune. We've got a story about this from Matt Williams. Right now, NASA doesn't have an administrator. Well, it has a temporary administrator, which is Sean Duffy, but he's the transportation secretary of the US. And so he's got a bunch of hats that he's trying to wear. And the normal thing that a presidential administration does is they choose a NASA administrator when they come in. And it was believed that Jared Isaacman, who is a private astronaut and has done a bunch of private missions to orbit, was going to become the new NASA administrator, friend of Elon Musk's, and as just an avid space exploration nerd. He was pitched back in December that he would become the new NASA administrator. And then Trump and Musk had a falling out in May, and Trump was concerned about the background of Jared Isaacman and decided, no, we're not going to nominate him as the NASA administrator. And so Sean Duffy became the temporary administrator. But now he's back. And so there was some change of heart in the White House administration, and they decided to put Jared Isaacman's name forward again. And so this week, the Senate had a confirmation hearing and voted in favor of him becoming the administrator with a pretty large margin. And so, unless something super weird happens, he is on his way to becoming the new NASA administrator. And, while he was waiting for his chance to become the administrator, he has written some strategic documents about what he hopes NASA will become. During his hearings, he talked about how he's a big fan of mining on the moon to try and gather local resources to support space exploration. He's really got moon fever and, wants to try and make sure that the US is the one that returns to the moon before the Chinese make their landing attempt, probably in the 2030s. He's also a big fan of private and public partnerships. So these kinds of commercial deals that you see with NASA and SpaceX or Boeing, or things like that, where instead of, say, building all of the rockets themselves, NASA farms this work out to other providers or pays for having payloads delivered to the surface of the moon at a flat rate. And so, when Jared Isaacman becomes the new NASA administrator, I think we'll see a resurgence in a lot of those ideas. And then, one sort of pet idea is that he had originally proposed that the Hubble Space Telescope could be reboosted with a private mission in a Crew Dragon. And so, now if he's NASA administrator, does he get to approve his own idea for a mission? I guess we'll have to see what happens. And he's also said that he's quite a fan of NASA's partnerships and support with universities and research institutions, and this has been a very difficult time for universities and research institutions right now. So it'll be interesting to see what kinds of relationships can be repaired on that front. And of course, the question is he going to get budget, right? Like the White House has wanted to slash the budget of NASA. That has been halted by various votes from Congress and the Senate, but we'll see what happens into future years. There's growing evidence that the planets weren't always in their current places in the solar system, that a long time ago, shortly after the formation of the solar system, they were much closer together. And then some event, something, caused them to migrate outward away from the sun. And in fact, it's believed that Uranus and Neptune switched places, and even this might explain why Uranus has rolled over onto its side. And this is known as the Nice model, named after the city in France, not the Nice model. but it's pretty nice. And there's plenty of evidence that supports this idea. There are co-orbital asteroids with Jupiter. There's the structure of the Kuiper Belt. Like, there's a bunch of independent lines of evidence that give astronomers an indication that this migration happened somewhere about 5 to 20 million years after the formation of the solar system. But what caused it? There's a bunch of ideas. One is that just as there was leftover material in the solar system, and as the giant planets were scooping them up, they were spiraling outward in search of food. But a new theory proposes that, in fact, you could explain the current location of all of the planets in this migration with a rogue giant planet passing through the solar system. They ran thousands of simulations. They tried different masses of planets, different speeds, and they found that when you get between sort of 3 and 30 times the mass of Jupiter, and you have an object come with about 20 astronomical units of the sun, so away from the inner system, but able to interact with the outer planets, moving at about, say, 5 kilometers per second, then you can get it to cause this migration of the planets outward. And so that's interesting. Obviously, what would be the chances that a giant planet happened to roam through the solar system in the first 5 to 20 million years of when the solar system was forming? But still, it's nice to have a nice explanation for that. But then as we see migration happening in other star systems, like, how do you explain those ones? So this is still a bit of an unsolved mystery. We've got a story about this from Mark Thompson. All right, it's time for another Tatooine story. You know how this goes, right? Like, astronomers find a planet that is in a binary star system or even a multiple star system, and then boom, out come the sci-fi references. And they show pictures of Luke walking on the surface of Tatooine. We're probably doing it right now. Well, that's it. That's the end. What we're going to talk about is that astronomers have directly imaged a planet orbiting around a binary star system. And this has been done before, but in the previous case, the planet was extremely far away from its stars. In this case, the planet is relatively closer. So the planet is a super Jupiter, has about 6 times the mass of Jupiter, and it orbits at about 60 astronomical units, which is farther than the orbit of Pluto around the sun. It takes about 300 years to complete one orbit. But that's enough of a gap from the star that astronomers were able to directly observe it. They block the light from the stars and then reveal the planet that is orbiting around them. And one of the big questions is, how can you get a planet that is this far out, that is orbiting 2 stars? Because most circumbinary planets, that's the technical term for this, you get that from gravitational instabilities around the 2 stars. The 2 stars form, they've got a sort of disk of gas and dust around them, and the 2 stars interacting can help force planets to form around them. But this one is much farther out, as if it migrated. Maybe that same giant planet moved through. But whatever happened, it was fairly recent. The planet is only about 13 million years old. So another idea is maybe it's a core accretion, and then it migrated, with or without that giant planet. But I really love direct images of exoplanets, not, the radial velocity method or the transit method where you have to look at a bunch of numbers to know, or a graph. You're actually looking at a planet around a star, or in this case, 2 stars. Anyway, we've got a story about this from Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was the discovery of sugar in samples from asteroid Bennu. So thank you everybody who voted. Now we're going to put the vote for this week's episode into the post tab here on our channel. So go there, vote for the story that you like. Of course, the best chance, subscribe to the channel, click on the notifications bell, interact with our polls, and then the YouTube algorithm will know that's what you like. Astronomers have used the James Webb Space Telescope to confirm that there is a supermassive black hole that is on a runaway trajectory, an escape trajectory from a pair of galaxies. And this was suspected, and several months ago, astronomers released a paper saying they think they've seen the first example of one of these runaway supermassive black holes. It's located in a pair of galaxies, which are known as the cosmic owl. It's actually a pair of ring galaxies that are about 8.8 billion light years away from us. And they are very close, and they're a strange shape, and that's probably caused by the fact that they have interacted with each other. You get other examples of ring galaxies, and they're often caused by galactic interactions. And so astronomers were examining the cosmic owl galaxy, and they saw this 200,000 light year long tail of something coming out of this region. And they suspected that this was a supermassive black hole that had been ejected out of the system. And so they're able to use James Webb, examine the area very carefully, and they were able to detect the presence of a bow shock. So in other words, the supermassive black hole is speeding through the intergalactic medium at 600 kilometers per second. You're getting material that is building up ahead of the supermassive black hole and its accretion disk as it's moving through the universe, and then that is glowing, and they're able to detect its presence. So thanks to James Webb, they were able to see sort of all these details, the tail, the bow shock, and that tells them that you've got this supermassive black hole that's speeding away. Well, how do you get a supermassive black hole speeding out of a galaxy? There's a couple of ways. One is that you get some kind of three-body interaction. So maybe there were three supermassive black holes, one in each of the two ring galaxies, and then this third one, and as they all came together, this guy got kicked out. The other possibility is that you could get essentially a bounce, a recoil coming from a collision between supermassive black holes. The gravitational waves, as they're coming together, cause so much of a kick that a much smaller supermassive black hole, relatively speaking, we're still talking millions of times the mass of the sun, but anyway, they can get kicked out of this collision area and speed away. And it's like a little unnerving to know that there are supermassive black holes speeding through the universe at 600 kilometers per second, and they're largely invisible, and they're out there right now. Anyway, we got a story about this from Evan Goff. And speaking of supermassive black holes, we know that there are supermassive black holes in about 90% of the large galaxies that are out there, galaxies like the Milky Way or Andromeda. And the way astronomers find these supermassive black holes is looking in X-rays. So even if a black hole is actively feeding or not, it's going to be producing some amount of X-ray radiation. They're always feeding like a little bit. And so when you point a very powerful X-ray telescope at a galaxy, you will detect the presence of X-rays coming from it. And that tells you there is a supermassive black hole. And then there's other ways that you can confirm its existence as well, but that's one of the best ways. And so astronomers said, okay, we know that there are supermassive black holes in the big galaxies, but what about the dwarf galaxies? And so astronomers recently completed a survey where they looked at a bunch of dwarf galaxies, smaller galaxies, to see if they also had that characteristic X-ray radiation coming from the supermassive black hole. And they only found that it was happening in about 30% of the dwarf galaxies and not that 90% that you see with the bigger ones. And this is interesting because there's also growing evidence that there are intermediate mass black holes in some of these dwarf galaxies. So not galaxies with millions of times the mass of the sun, but galaxies with thousands of times the mass of the sun. And there's more and more of these have been found in these dwarf galaxies. So it could very well be that you get this sort of sizing of the black holes that relates to the mass of the galaxy. And that kind of makes sense. Anyway, we've got a story about this from Matt Williams if you want to read more. Well, we've crossed a big milestone. The Nancy Grace Roman telescope is complete. And this was kind of dicey because the last time President Trump was in the White House, one of the things that the administration tried to do was cancel the Nancy Grace Roman telescope. And then it was saved by Congress and the Senate and continued its development. And now on November 25th, engineers at NASA united the two parts of the telescope, attaching the telescope to the solar array sunshield. So now the telescope is assembled. So the next thing to do is to test it. And so we're going to see a range of tests where this thing is put into vacuum chambers, heated up, cooled down. And a lot of that stuff has already been done on individual parts. Now they integrate the whole thing together and test it. And if all goes well, Nancy Grace Roman will launch in spring 2027, but it could be done as early as fall 2026. So it might come in ahead of schedule. That would be great because this is another big instrument that's going to help join the search for understanding of dark matter and dark energy. it has this leftover mirror that was provided by the Department of Defense to NASA several years ago. We've got a bunch of these reconnaissance mirrors left over from Hubble class telescopes designed to look straight down at planet Earth, and we don't need these two. Can you think of anything to do with them, NASA? And NASA said, yes, we could make a very wide field telescope that could give us really great images of the universe. And they said, yeah, do whatever you want. So NASA turned one of these mirrors into the Nancy Grace Roman telescope. And even though it's about the same size as the Hubble Space Telescope, it has a field of view that is 100 times larger. And so that's one instrument, is this thing called the Wide Field Imager. And it's going to be able to take just enormous infrared images of the universe and be able to help astronomers sort of map out the distribution of dark matter and regular matter and dark energy throughout the cosmos. And then the other instrument on board, which I'm probably more excited about, is called the coronagraph instrument. And this is a precursor, a prototype for the kind of instrument that might eventually be installed on the Habitable Worlds Observatory. While the HWO will allow astronomers to look at Earth-sized worlds orbiting around sun-like stars and measure their atmospheres and so on, this should allow the Roman telescope to be able to observe Jupiter-sized worlds orbiting around sun-like stars, which is still an observation that is very tricky when they're that close. Hopefully, in late 2026, early 2027, we should see Nancy Grace Roman launched and we get an entirely new mega space telescope in space. We've got a story about this from Evan Goff. I hope you're enjoying this episode of Space Bites here on YouTube, but this isn't the ideal watching experience for a bunch of reasons. One, YouTube likes to put a bunch of ads into our videos, and we don't want them to put a bunch of ads into our videos. And so we try to show you a version that has no ads. Also, YouTube has an indirect connection between us and you. In other words, whether or not you get to watch our videos depends entirely on how the algorithm is feeling on any particular day, and that algorithm can be cranky. So you should sign up so that you'll get notifications whenever we've released new videos. And the best way to do that is to go to Patreon. Now, we post every single video that we do here on YouTube over on Patreon, and to celebrate the better viewing experience over there, we make a version with one additional story. And the additional story this week is about how astronomers have searched for an intermediate mass black hole in the Omega Centauri cluster. Did they find it? You're gonna have to watch that video to find out. I'll put a link in the show notes. You can just click over there. There's no payment required. You don't have to become a patron. You can just watch it for free with no ads. And that's what's best. Of course, this is just a fraction of the space news that we're covering this week over on Universe Today, usually 30 to 40 stories. And the best way to kind of wrap your mind around everything that we're covering on Universe Today is to read my weekly email newsletter, which I send out every Friday to 70,000 of my closest friends. It's completely free. I write every single word, no AI. You can subscribe. Go to universetoday.com/newsletter. I'd like to talk about taking control of your online experience. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradorn, Chuck Hawkins, Commander Bielak, Cy Nelson, Dark Finga, Dave Veribuff, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Renkaidu, Richard Williams, Sean Sargent, Stephen Fowler Melly, Team 49, Telescopes Canada, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we get messages all the time here on the channel where people say, I thought I was subscribed to you. I'm sure I was, and now I'm not. And I don't know what happened. And I didn't realize you were still producing videos. Clearly this is a big problem. And I'm sure many of you who are watching this right now feel like you just literally can't trust your subscription system through YouTube to the kinds of things that you enjoy. And instead, you are reliant on algorithms that are sort of fine-tuning your experience of the internet. It's happening on TikTok. It's happening on your news apps. It's happening on Facebook, on whatever you use. There are algorithms that are trying to modify what you see. And the problem is that they're not trying to modify what you see for what's best for you. They're trying to modify it for what's best for them, what makes them the most money, really. And what makes them the most money is to enrage you, often to make you feel distrustful and skeptical of your friends, your neighbors, like it's pretty dark, man. And there's some great documentaries that kind of show you what's sort of how these algorithms work and what effect this is having on our human brains. And no one's coming to save us, right? That I think the big tech companies, they need to make money. The government in the pocket of the big tech companies. And so we're going to live in this world of algorithmic enshittification for a while before either we all just say we're sick of it, we don't want it anymore, or we're going to see these companies go under because, they've overstepped their boundaries. Or they've tried to strip away every last bit of sort of value out of both us as the viewers as well as the people who pay for it. And there's no blood from the stone to be left. But you don't have to let them do this to you. You need to take control. And I want to sort of propose a bunch of ways that you can do this. And that is to sort of really choose and curate the way you experience YouTube and the rest of the internet. So a good example is, instead of just going to the YouTube homepage like a robot, typing youtube.com and going there and then clicking refresh on your page, bookmark your subscriptions page on YouTube and make that the place you go. And so instead of going to www.youtube, click on the bookmarks bar, go to the YouTube subscriptions page, and then you will see all of the channels that you are subscribed to. There is no algorithm that is choosing those for you. You are doing this on your own. The other thing that I really like is using an RSS feed, which is like old archaic technology, but essentially you would subscribe to a bunch of websites and you would subscribe to their RSS feeds, and then you would read your news in the RSS feed. And when you would reach the end of the news stories, you were done. You had finished the internet for you. You had completed it. Now you can move on to something else, like touching grass, hanging out with friends and family, reading a book. I don't know. And there are a lot of email newsletters that you can sign up to. You give them your email address. They send you information on a regular basis. If you don't want it anymore, you unsubscribe from it again. And that, when you think about the way you interact with the internet, really think carefully about how you are connecting with this material. Are you choosing what you're seeing, or is an algorithm choosing it for you? And of course, because we are no longer funded by advertising at Universe Today, that we're 100% supported by the patrons, we lean entirely on the sort of direct ways, the RSS, the podcast, the email newsletter, and hopefully subscriptions here on YouTube, and want to sort of really encourage people to get away from where you just let an algorithm choose for you, because it does not have your best interests at heart. So I hope this helps. Let me know how you curate your own experience on the internet, and we'll see you next time.